In this video, I'm going to show you how to solve a typical problem that traditional methods refer to as the mixed compound rule of three or mixed proportionality of magnitudes. But the first thing I need to say is what I've already told you in all the previous videos, that this direct or inverse proportionality between magnitudes is not correct to apply because inverse magnitudes do not exist, alright? And another problem with the classical methods is that they rely purely on intuition. There is no general proof for any particular case, which is what characterizes mathematics or physics, right? That's a shortcoming of traditional methods, and that's precisely why I'm here. What I'm proposing to you is a method based on the First Algebra of Magnitudes, and I have been able to prove that it is applicable to any general case. I'll leave a link in the description to the articles in Spanish and English with the same content, where I provide the corresponding verification so you can check it for yourselves. But in this video, I want to show you with a specific example that says the following. If 8 workers build a 30-meter wall in 9 days, working 6 hours per day, how many days will it take for 10 workers, working 8 hours a day, to build a 50-meter wall? Alright, first of all, as the first step, the first thing you need to do is learn to distinguish between the statement of the problem and the actual question being asked. In the statement, we have all the measurements with their corresponding quantities. However, in the question, we have those same measurements from the statement, but one of those quantities is unknown. So let's take a look at it. For the statement, what does it say? If 8 workers build a 30-meter wall in 9 days, working 6 hours per day, that's our statement. We have all the measurements and we know absolutely all the necessary data. What do we need to do? We need to establish the equality between the measurements that represent resources and those that represent work. And that's the equality we're going to pursue, first for the statement on one hand and then for the question on the other. Great. What essential resources do we currently possess and have at our disposal? We specifically have 8 dedicated workers, combined with 9 full days, which is also further combined with 6 productive hours per day. And those are indeed the 3 primary resources we currently have available. Now then, what exactly happens next? Here, we're working with algebra of magnitudes. It's not just arithmetic, okay? That's precisely the problem with the classical methods. Not just because that's the case in the rule of 3, no, it's that all of physics falls into the problem of arithmetization. That is, they eliminate magnitudes from the operations, try to explain the magnitudes, and end up forgetting about the magnitudes themselves in the process of explaining them. In other words, it's a very curious thing, but it happens. Since we're dealing with algebra of magnitudes, how are we going to combine these 3 measurements which are of different dimensional elements? That is, they have different magnitudes. On one hand, we have workers, that's one magnitude. On another, we have days, that's another magnitude. And then we have hours per day, which is yet another magnitude. How do we combine them? With a geometric multiplication. And since we're working with algebra of magnitudes, not arithmetic, we can't represent that multiplication with a dot or an X. Instead, we use an asterisk, in accordance with the original algebra of magnitudes. Alright, and what does this equal? Well, this equals the final work that we achieve, which in this case is 30 meters of wall. Alright, so now we have the proportion of magnitudes for the case described in the statement. Now let's find the proportion of magnitudes for the case in the question. Following the sum, well, first of all, the question says, how many days will it take 10 workers working 8 hours a day to build a 50-meter wall? Alright. Following the same order as the proportion in the statement, do we have workers? Yes, in this case, we have 10 workers. In geometric combination with how many days? Well, that's our unknown. Days, the magnitude is still the same. What has changed is how many days. So there we have x days. In geometric multiplication with how many hours per day? 8 hours per day. So 8 hours per day. And now we have all the resources from the question. And what is that equal to? Well, that's equal to 50 meters. Now we have the 2 proportions, one for the statement and one for the question. How do we continue? Well, look. If we divide each term of both equalities, we end up with a single equality. In other words, just with that dividing line, we've obtained the complete proportion of magnitudes for the entire problem. What's the issue? Well, it's not really a problem, it's just a clarification. We're working in the algebra of magnitudes. We haven't eliminated the magnitudes, we haven't fallen into the trap of arithmetization. Therefore, we can't represent that division as we do in arithmetic with a single horizontal line. Respecting the original algebra of magnitudes, we'll use 2 horizontal lines. And that's it. Now we have the complete proportion for the problem perfectly described, detailed, and symbolized. What's the next step? Well, the original algebra of magnitudes has shown that when a magnitude is divided by itself, the result is the abstract number known as unity. Workers divided by workers, that's 1. Days divided by days, that's 1. Hours per day divided by hours per day, that's 1. Meters of wall divided by meters of wall is the last one. So what happens here? Well, from this point we precisely get an arithmetic operation, specifically 8 multiplied by 9, then that product multiplied by 6, all of which is then carefully divided by the quantity of 10 multiplied by x, and then that product multiplied by 8. This entire expression ultimately equals the ratio of 30 divided by 50. So now, just by solving for x, what is x equal to? Well, let's meticulously break down this mathematical expression. It is precisely equal to the product of 8 multiplied by 9 and then further multiplied by 6. This entire product, which forms the numerator of our fraction, is then divided by the product of 10 and 8, which constitutes the denominator on one specific side of the equation. Following this, we multiply the result of that initial division by the fraction of 50 over 30. This comprehensive calculation, when performed step by step and with careful attention to each operation, ultimately and definitively gives us the final numerical value of 9 as the conclusive outcome. 9 what? Well, going back to the measurement, where we had the unknown, which was x days, we see that it's 9 days that it takes for 10 workers, working 8 hours a day, to build a 50-meter wall. And it's that simple. If you want me to solve a specific problem, leave it for me in the comments. And what I do ask of you, please, is to help me spread the word about this method for solving typical problems involving the rule of 3 or proportionality of magnitudes, because here, I insist, we are actually doing true proportionality of magnitudes, not what is usually taught. Thank you very much.